Hello, this is Algebra 1, Topic 3-1 on single variable inequalities. Now you solve inequalities the same way you solve equations with this one singular difference. And that's when you multiply or divide both sides of an inequality by the same negative value, you must switch your inequality symbol. So let's go ahead and put this into practice. This is just a simple one-step inequality. I want to get the y by itself, so I need to get rid of this negative 2. That means to make it go away, I need to add 2. What I do to one side, I must do to both. Leaves me with nothing but y on this side, because that cancels. And 6 plus 2 is 8. Got in the habit of writing the equal sign. We don't want to put the equal sign, we want to put the less than sign. And so our solution is that y is less than 8. Now, on the number line, we're going to go ahead and just put 8 right here in the middle. And the question is now whether do I circle it or do I put a dot there? Well, because this is less than and not less than or equal to, that means that I'm not exactly 8. Since I can't be 8, I'm going to put an open circle. And now, because we are less than, I'm going to shade less than. Make my arrow a little bit bigger to help delineate that, yes, I've shaded this side. Okay? Now, a couple of ways you can think about this. I'm going to go ahead and put 7 and 9 on my number line, and I'm going to go ahead and just try some numbers. Is 7 less than 8? Yes, so the 7 needs to be shaded. Is 9 less than 8? No, so I don't shade the 7. I don't shade the 9. I do shade the 7. I can come back up here and test it. 7 plus negative 2, that would be 7 minus 2, which is 5, and 5 is less than 6, so I shade the 7. 9 plus negative 2 would be 7, and 7 is not less than 6. I don't shade the 9. But the easiest way is if your variable is on the left-hand side, you follow the direction of the sign. It's pointing to the left, so we shade to the left. Let's go ahead and look at number 2. Well, it's like a one-step equation. I need to get rid of the 8. And this time I need to divide, because 8p means 8 times p. And to undo it, we divide. Well, negative 8 and negative 8 go away, leave me with just p is, I'm going to go put equal to right now, even though I know that's not right. And negative 32 divided by negative 8 is 4. Now, the question on my sign. I divided by a negative. That means that my sign must flip. P is less than 4. So I'm going to go ahead and put 4 on my number line. I'm going to go ahead and put 3 and 5 as well. There's no equals bar, so I will just circle 4. And now I check. This says I should shade it to the left. And I know 3 is less than 4. But let's try this. Negative 8 times 3 gives me a negative 9. And negative 9 happens to be greater than negative 32. So that makes this true if I include the 3. So I'm going to shade in the direction of the 3. And now I move on to example number 3. Now we get to a two-step equation. First, we get rid of the 12 by subtracting. Leaves me with 3a greater than 18 minus 12 is 6. Divide both sides by 3. I get a and 2. Now I've got to see, did I multiply or divide by a negative number? And the answer is no. So my sign stays the same. A is greater than 2. 2, go ahead and put 1 and 3. And so if I plugged in 3, 3 times 3 is 9, and 9 plus 12 is 21. 21 is greater than 18. So the 3 is the direction I need to shade. Also, my variable's on the left, and the arrow points to the right. And now we get to an equation that's got variables on both sides. And the first thing we're going to do is get all of our t's to one side. So I'm going to go ahead and just subtract 9t. That gives me 5 less than or equal to t minus 3. I add 3 to both sides, and I get that 8 is less than or equal to t. Did I ever multiply or divide by a negative number? My answer is no. But I want to go ahead and rewrite this as t is greater than or equal to 8. Now the reason I did that is because if my variable is on the left, then I've got no problem. Now I want you to notice that this sign and this sign are reversed because I reversed my numbers. 8 is less than t. Go ahead and put 8, 7, and 9 on here. So if I put t equal to 7, 8 is not less than 7, so the 7 doesn't work. But if I put a 7 in for t, 7 greater than 8, it still doesn't work. I want to make sure that that's actually true. So I circle the 8. I know the 7 doesn't work, which means the 9 does. And I get my answer. Moving on to example number 5. Here we've got a multi-step equation that's going to start us off with a distributive property. And I get that 7a less than 3 plus 7a minus 7. Now we combine some similar terms. 3 minus 7. I get 7a is less than 7a minus 4. Get all my variables to one side. I'm going to go ahead and subtract 7a from both sides, and I get that 0 is less than negative 4. Well, my variable has disappeared. It's gone away. Sometimes this happens, and when it does, you want to think, is this true or false? Is 0 less than negative 4? Well, let's put negative 4 on here, and 0 will be over here to the right. So is 0 less than negative 4? No, 0 is greater than negative 4, so this would be false. Because we have a false answer, our answer is no solution. Alternatively, we could just draw the circle with a slash through it that represents no solution. Now this happens when we get a false statement. Let's take a look and see what example number 6 shows us. I'm going to start off with distributing negative 5x plus 15 less than negative 5x plus 1. I'm going to add 5x to both sides, and I get that 15 is less than 1. Fifteen is less than 1. Well, is this true? Or is this false? Well, let me go ahead and put them both on. I'm going to start with 1, and then 15. And 1 is less than 15. 15 is greater than 1, so this is also false. Now, had this been true, I would have used all real numbers. But it's being false, and so we use no solution. Oh, hold on. I just noticed an error. When I multiplied this negative sign, I forgot that this makes this negative. Okay? And so this is negative 15. And 1. And 0 would be about there. And so yes, negative 15 is less than 1. And so my answer is true. We're talking all real numbers. And so yeah, this is true. And so on a number line, we're actually going to shade the whole thing. Whereas on no solution, we don't shade anything. All right. Sorry about that error. Let's go ahead and move on to number 7. Here we have inequality, but it's got 2 signs. And so this is fine. There's a couple ways I can solve this. I can actually break this down into 2 separate inequalities, or I can solve it as 1. I'm going to show you how to solve it as 1 right now. The idea is that anything I do to one portion, I have to do to all 3. So if I subtract 1 to get rid of that 1, I need to do that over here and over here. And so negative 7 minus 1 is a negative 8. We're left with 2x, and that becomes 8. Now I need to divide by 2 to cancel here, so that means I need to divide by 2 everywhere, and I get negative 4x and 4. Put my symbols. And so I can just copy this down. Negative 4 is less than or equal to x, which is less than 4. And I'm going to go ahead and put those on. Negative 4, 4. I'm going to go ahead and add 0 because I know 0 is in between those. And x is going to fall in the middle. Now, one other thing that's new about this is here we have an equals bar. Because it's an equals bar, I actually get to fill in that bubble because x can be negative 4. X is in fact anything from negative 4 to everything except 4. We stop at 4 and we don't actually include it, but we are including negative 4 here. And our last example is a rather long one, but we'll work it out just like we do an equation. So I'm going to start by distributing. So 5k plus 20 minus 2k minus 12 greater than 5k plus 5 minus 1. Combine similar terms. 3k plus 8 greater than 5k plus 4. Move all of my k's to one side. 8 greater than 2k plus 4. Move my regular numbers to the other. 4 greater than 2k. Divide both sides by 2. Now, did I ever multiply or divide by a negative number? Answer is no, but I do need to switch this into k less than 4. Now, another way you could have solved this, just so that you see this, is instead of subtracting 3k, I could have subtracted 5k. And that would have given me a negative 2k plus 8 is greater than 4. When I subtract that, I get a negative 2k greater than a negative 4. Divide by negative 2, and I get k is less than negative 2. I apologize for this error over here. 4 divided by 2 is 2, not 4. And because it's negative, I flip it. And so, notice that we get the same thing. The difference is that here I had to divide by a negative number and flip my sign, whereas here I just flip the equation at the very end. Either way, we're going to go ahead and circle the 2, and we're going to go to the left. And so this was topic 3-1 over inequalities. It's just like solving equations, except for you have one last thing to check at the end. Good luck on the assignment. Have a good day.